Hello, we are from Group 16. My name is Jenwit Thitikawin.
Hi, my name is Krittin Limotai.
And today we are going to present about our microcontroller project, which we are doing a circuit that can determine the quality of the water.
And this is concept of our project. This project is used for check how clear or dirty water is using turbidity sensor and Arduino. The sensor sends a signal to Arduino which calculates the water turbidity level. Project purpose. Object is a continuously measure the turbidity of a water sample and classify it into the three categories: clear, cloudy, and dirty, and it have alerts. A green LED indicate water is clear, yellow LED is indicate moderate turbidity, and red LED plus busters indicate the high turbidity.
So here is our circuit. Let's start off with this one. This one called turbidity sensor. It has a 3 wires. The red one is a anode sensor, the blue one is a cathode sensor, and the yellow one is the output, which all of the wires will connect to a module, and the module will have all the label with a GAV. The V one stands for the VCC, so we connect the VCC to the breadboard here, and then we using G, which stands for a ground, we connect it to the ground node here with the white wires, and then the blue one is stand A is mean for A in a Arduino port, so we connect this one to A0. Next, let's move on to Arduino board. For the Arduino board, on the orange wire we are using a 5V VCC, so we connect this one to a breadboard, and for the ground we connect white wires to cathode in the breadboard too. And then here, as you can see, we have a 3 output LED pin, which are green, red, and yellow. For the ground, we connect the LED pin using a 330 resistor. And then on the output pin, we connecting the output on the Arduino, which are 2, 3, 4, and 5 respectively. And then for the last one, here's our buzzer. It has a ground pin and the VCC pin. So the VCC and ground pin are connecting into the breadboard too. And then the input output, we connect it into the 5 on the Arduino. Okay, so let's move on to our demonstration. First, we have 3 cups of water and 3 LEDs. The first cup of water, which are the fresh water. The second cups of water are the cloudy water. And the third cup of water are dirty water, which we mix it with the dirt. Next, we are going to put a turbidity sensor in the fresh water. So as you can see here, if we put the sensor in the clean water, the green lights will appear up. And if we put a sensor in the cloudy water, as you can see here, the yellow LED will show up, but this one will not light up like other. I don't know why. I have changed a lot of LEDs, but it still be the same output. On the third one, if we put a turbidity sensor in the dirty water, the red lights will appear up and the buzzer will buzz.
Now, I will walk you through the Arduino sketch that read a turbidity sensors compute water clarity in NTU, and drive LED and a buzzer based on threshold levels. We will examine each line so you understand how the pin definitions set up, sensor readings, calculations, and output control all work together. This line is defined the turbidity pin AO is assigned the analog input AO to the read the turbidity sensors, and define green LED too. It means give description name to the digital pin driving status LEDs. Green, yellow lights on the pin 2, 3, and 4. And define buzzer files is the name digital pin files for the buzzers. Why we use defines? We use define is make the code to make a readable and easy to change pin assigned in the one place. Now let's move to the setup line. This line is a serial.begins 3600 is the initial serial communication at the 9600 BTS for the debug pins, and the pin mode outputs in here is mean configure the green LED, and this one is a red LED, and this one is buzzer as a output. And that we note that we omit the yellow here. That is a small overlay slide ideal we have set it up to. And this one is a digital write buzzer high. It sets the buzzer pin high initially, assume as a active low buzzers, high silence it at starts. Now let's see at the beginning of the loop and sensor reads. Here is an analog turbidity pins. Is a lead value of 0 to 1023. The turbidity sensor analog output stored into raw. And is a voltage T is calculations is a convert raw ADC count to the voltage 0 to 5 volts, and is used to raw multiple to the 5 divided by 123 is using 5 for 5 volt difference. If your board is 3.3 volts, it's adjust here. And next is a NTU police is a formula to apply linear models to estimate NTUs. This comes from calibration equations. Your sensor may need different slope or intersections. Next, let's see the serial pins here. Serial outputs here and serial pins is a send format text to the serial monitors, pin the voltage with 2 decimal place, pin the compute NTU with 2 decimal, then a new line. Purpose is a real-time debugging and logging, so we know our calculation is loop iterations. Next, we're gonna look at the decision logic outputs. This part we use threshold to check the turbidity value in the sensors. Let's look at this line. If the turbidity value is more than or equal to 13, it means it's good qualifies. It will turn on the green LED on and silence buzzers and turn other off. Next is L lines. Is check if turbidity value is less than 13 and turbidity value is more than minus 3. It means it's a moderate turbidity or cloudy. Yellow LED is turned on and buzzer still silent, and red LED is turned off. And next is else. It means the quality of the water is very low. Is the red LED is turned on and activate buzzers for the active loads. While this lens the threshold is reflected to calibrate for the clears, cloudies, and dirties. Adjust 2 units. Important we set the buzzer loads in the last band to sound alerts. So if you have a opposite buzzer type, is in with the logic. Next, the last one is a delay. Delay is used to pause the loop for 1 second before it's repeating. It provides a human readable update rate and prevent floating the serial port too quickly. To summarize this code, we have pin definition and define macros. We have set up for serial and pin mode. We have reading analog sensor and voltage to NTU conversions. And we have the sensor debugging outputs. And we have a condition logic to drive LED and buzzers. And the last one, we have a loop timing with delay. To summarize this code, we have pin definition and define macros. We have set up for serial and pin mode. We have reading analog sensor and voltage to NTU conversions. And we have the sensor debugging outputs. And we have a condition logic to drive LED and buzzers. And the last one, we have a loop timing with delay. This project uses a simple analog sensor with straightforward microcontroller logic to deliver efficient turbidity monitoring solutions, complete with visual and audible alerts, serial login, and a foundation for more advanced features in the future. Thank you for watching.